Welcome to another video. In this video, we'll be talking about nodal analysis, another technique of circuit analysis. And the driving concept behind nodal analysis is that each node has a particular voltage when compared to another node. Take, for example, if you were to put a voltmeter, a voltmeter's negative terminal here, and you were to take the positive terminal and put it here, you get a reading on the voltmeter. If you were to come here, you get a different reading. So that's the basic idea, basic driving concepts behind nodal analysis. The second very important principle that drives nodal analysis is the Kirchhoff's current law. Nodal analysis basically provides a different approach to applying Kirchhoff's current law. As we proceed in the video, you'll see exactly what I am talking about. I'll proceed to introduce the steps that we need to follow when applying nodal analysis. So the first step when we want to apply nodal analysis is to identify essential nodes. So essential nodes are nodes that have at least 3 branches connected to them. So in this case, our essential nodes are this node, and this node, because they have 1, 2, 3, 1, 2, 3, 4, and 1, 2, 3 branches connected to them. So we have 3 essential nodes in this case. Then step 2 is that we select a reference node, and then we number all other nodes. So let's say out of the essential nodes, we pick this as our reference node. So we put a ground here. Then we number other nodes. So this will be node 1 and this will be node 2. By picking this node as our essential node, what we're trying to say is that if we wanted to measure the node voltages with a voltmeter, we will put the negative terminal here. Then we will measure this and we will measure this. Then we'll get our reading on the voltmeter. Or if we are choosing this as our reference node, then that would mean that we put our negative terminal here, then we measure this node voltage and this node voltage. That's what it means to choose a reference node. And you have to note that the voltage at the reference node is 0. So the node voltage at the reference node is by default 0. The next step is to write KCL equations at each node. Doing this is pretty simple. So let's do an example. Say at node 1, we want to write the KCL equation there. So let's say the voltage at node 1 is V1. So what we say is that we write the current in this branch. So we say the current in this branch is the voltage V1, that's the node voltage here, minus the node voltage V2, that's minus V2, divided by the resistance of the branch, which is R2. Note that by doing this, we are assuming that the current is flowing outward from the node 1. So that means that this current that is flowing inward into the node, that's current I1, will take a negative. Since this takes a positive sign, that means that this current will take a negative sign, which is I1. Now, this current I2 is flowing out of terminal 1, and we have assumed that the current is flowing, the positive currents are flowing outwards, so that will be plus I 2. Then we write for this branch. So that would be plus V1 minus 0 divided by R1. And by KCL, the summation of all these currents is equals to 0. And this would be our first equation. We can simplify further, but this is just an explanation, so no need to go through all the stress. Then we come to node 2 and write the KCL at that node. So at node 2, we say V2 minus V1. That's the node voltage at V2 minus the node voltage at V1 divided by R2. That is the current flowing out of node 2. So that would be V2 minus V1 divided by R2. That's the current flowing out of node 2 through this branch. Then the current flowing out of node 2 through this branch is minus I2 because it is in fact flowing in. Then the current flowing out of node 2 through this branch would then be plus V2 minus 0 divided by R3 equals 0. Now that you have these equations, you can move on to the next step, which is to solve the equations simultaneously. So you can easily just simplify this equation and solve them using your calculator or manually simultaneously. And by the time you're done with that, you would have the value of all the node voltages. Then you'll be able to use the node voltages to estimate the currents flowing through each resistor. Take for example, the currents flowing through this resistor, R2 in that case, would now be, say, I2. Okay, let's call that I3, would then be equals to V1 minus V2 divided by R2. And the currents flowing through this resistor would be V1 divided by R1. Plain old let's call that I4. That's plain old Ohm's law. And you would realize that nodal analysis seems to be easier than using Kirchhoff's laws to analyze the circuit. Thank you for watching the video. Do not forget to like and subscribe. Hit the notification bell to know when the next video comes up. See you later. Bye.